Hi, grade nines. So today we are going to learn about energy conversions. So at the end of this lesson, you should be able to explain how electrical energy can convert to thermal energy, light energy, mechanical energy, and then all of those but flipped back into electrical energy. So you should be able to identify and estimate the energy input and output for example devices and systems. So what does this look like? Well, first, actually, let's talk about what energy is. This is a key term here. So energy is defined as the ability to do work. Okay. So when we're talking about energy, we can take electrical energy and it can convert into many other energy forms, and many other energy forms can convert into electrical energy. So we're going to walk through quite a few of them today. So the first one is electricity to heat. So electrical energy to heat. So your electrical energy is your input, what we're starting with, your input energy, and your heat is your output energy. Heat is also known as thermal energy. Okay. So a couple examples that I would write for this would be stoves, toasters, hair dryers. They all take, right? We have to plug them into the wall, and then they convert them into heat. That is their intention. Okay. How they do this is they actually push the electricity through a conductor, but that conductor has high resistance, so it doesn't allow it to flow through easily, and therefore heat is produced. Now, you can take heat energy or thermal energy as your input. You can start with it and actually produce electrical energy. That's your output. And we do so through something called a thermocouple. Some of you may have heard of it before, maybe not, but these thermocouples, okay, are basically a fancy little system, and they've got some wires in them, and when they get heated, they make a complete circuit, and electricity is actually produced. I'm not going to go into crazy detail on that, but I would write that it's a device called a thermocouple. Okay. These thermocouples, okay, work through this concept called the Seebeck effect. And basically what it means is it produces a very small amount of current, and we often use these, okay, to do measurements of temperature. And so when they stick these wires into something to check the temperature, depending on the amount of current that is produced, it will give a certain reading. Thermoelectric generator actually uses this same effect. It takes thermocouples and attaches them all in series, and they can actually create quite a bit of current because of a temperature difference. So you can actually generate electricity just from heat that is being, the thermal piles getting heated up, and then it is cooled down. Okay. They are not great for a lot of power. They are pretty low maintenance, but because they don't produce a lot of power, they're usually only used for backup or emergency. All right, next conversion. So electricity to motion. So if you start with electricity, your input energy, and you end with motion, your output energy, this is often also referred to as mechanical energy. Okay. In the past, you've also probably heard of it as kinetic energy because it's that motion energy. There's many different devices that actually do this. Okay. So we plug something in and it moves. Usually we focus on motors and electromagnets in a whole nother section. We're not going to do that at this point. But another one that we often don't think about is our speakers that we use every day. So we plug our speakers into either a battery or right into the wall, so it's taking electrical energy, and that electrical energy actually causes crystals inside that speaker to move, and those sound waves will then move, and you get what you can hear out of your speakers. So I would write down examples: motors, electromagnets, and speakers, because speakers, right, get plugged into the wall, into your electrical socket, and they move sound waves, and therefore it allows you to hear, but AKA it's motion. Okay, they do this through something that's called the piezoelectric effect. I'm not going to go into crazy detail, but there are actually crystals within your speakers that actually change size when the electricity runs through them. They expand and contract and expand and contract, and that's what makes the sound waves actually move. Okay, usually those crystals are often made out of quartz. Okay, and you can see what happens here is, so this is a normal crystal. When it compresses, when the electricity is applied, it compresses, it contracts, and when the electricity stops for a split second, it expands, and it continues this process. If you are interested, I will link this video for you right in the Edpuzzle. Okay, now to flip this, so speakers are electricity to motion, but you can actually take motion, you can take mechanical energy and convert it into electrical energy as your output energy. The common everyday thing that we actually use to do this is a barbecue lighter. The only way a barbecue lighter works is if you actually push down on the clicker, right? So when you push, that's your motion, it's your mechanical energy, and it creates a little spark. You're going to say, well, it actually creates a flame. The only reason it creates a flame is because you have gas that's released when that spark is released. So the spark is actually your electrical energy. It lights the gas, and then you get thermal energy. Our next energy conversion is electricity to light. This one we see every day. It's probably the first one you guys noticed as a child. You're taking your lights that are plugged in all over your house, and they are converting that electricity to light. We know that some light bulbs aren't as great at doing this energy conversion as others, and that is dependent on what they have inside them for their resistor. So the electricity goes from your wall socket and it runs through your light bulb, and this part, okay, is your resistor. And that high resistance is what allows the metal to glow and produces light. Now you could tell me, yeah, this also does produce thermal energy. You are correct, but it's not its main reason or main intention for the light bulb. That is one of what we call a waste energy, and you talk about that more in grade 10. We know that some of the light bulbs like LEDs are actually a lot more efficient at doing this, and they don't produce as much heat. Okay. And this is just talking about how much little power they actually take. We end up using LEDs a lot more often because they also do last longer too. Okay, and our last one, light energy. So we can actually take light energy and convert it to electrical energy. And most of you guys know this. The example device that does this is a solar panel. Okay. In fancy science terms, this is called a photovoltaic cell. Okay, it's going to capture the light energy, and it is going to convert it into electrical energy. They are made up of semiconducting materials like silicone, and what happens is when the light actually hits the photovoltaic cell or solar cell, some of the light is actually absorbed by the electrons that are in there in the silicone, and it breaks them loose from their atoms, and it allows them to flow freely. And we know that if electrons are moving, we actually have current flowing, aka electricity. Okay. I'm also going to post this video as well, that if you're more curious or interested about how solar panels work, you can take a little deeper dive into that. As usual, if you have any questions or confusion, let us know, and have a good rest of your day, guys. Bye.